So now we have something to talk about called the intermediate value theorem. Well, I'm starting on example 3, so I'll just redo it in a second. But now I'm going to talk about it a little bit beforehand, and we'll get to the problem soon. But let's just understand what's going on with the intermediate value theorem. So if you want to talk about the intermediate value theorem, then you need to always state that the function is continuous. So that has to be true. Somewhere they have to say it, or you have to say it, or you have to know it's continuous on an interval a to b. So we'll say it's continuous. Say you have a continuous function on, we'll call it a to b. Now this is interval notation. It means from the x value a, including a, and the x value b, including b. So if you have a function that's continuous on a to b, and we'll draw this as a graph, we'll say, let's say f of a is equal to c, and f of b is equal to d. All right, now let's draw a picture of this. Now I'm going to make a should always be smaller than b, because again, if you're talking about interval notation, a should be on the left. Now, it doesn't really matter where these are on the x-axis. They could be slid around anywhere, but let's just say that they're here for argument. And let's say, for instance, that c, the value c, notice that's a y value, is here, and let's just, for case of example, put d right here. Okay, so from this picture, hopefully you would agree that f of a is c. That's what that means. The y value at the x value a is c, and the y value at the x value b is d. And we have a continuous function. Now what does that mean? It means, well, essentially the graph looks like a smooth curve in its connection from a to b. So what it means is I have to keep my pencil on the page and I have to draw a line from a to b. Now I can do that however I want. It could be as simple as this, there. That's continuous on a to b. In between a and b, there's no breaks, there's no jumps, there's no holes, it's connected. So you can't lift your pencil on your way to a to b. That's the non-mathy way of saying it, but it gets the point across. Literally gets the point across because you're connecting the points. Wow, I don't think I made a joke in these videos yet. Okay, anyways, now it doesn't have to be a straight line. It could be something wacky and crazy. It could be like this. Okay, now think about what this means. It means, in this case, I kind of like this idea of a wacky example. There are a lot of y values I encounter in between a and b. There are. But because I'm connected, here's really what the intermediate value theorem says. As long as as long as your function f, is continuous from a to b, then at some point you are going to encounter every y value in between c and d. So in other words, because x is continuous, because you have to draw a straight line that never breaks, your y values are at some point going to have to cover everything in between. So all these y values are guaranteed somewhere in between here because it's continuous. So why does it need to be continuous? Maybe I'll put this to the side here. Every y value between here and here needs to be filled. Now you can see that that definitely happens right here. All those y values are guaranteed right there. It's also guaranteed here. It's also guaranteed here. It can happen in more than one place, but it has to happen at least once. That's what the intermediate value theorem says. Now what if it wasn't continuous? And then we'll start doing some examples. We'll start drawing some pictures that'll kind of make sense of this, and we'll be done pretty quick. So what if it wasn't continuous? Let me just draw you a crazy picture. Let's say I had some kind of graph that looks like this. Now see, I was trying to argue that every value in this range is guaranteed. But look, see, there's this pocket right about here where nothing is happening. There's no function value from here to here. And see, that's why it needs to be continuous. If it's not continuous, you can definitely get from A to B. It can definitely actually be defined everywhere. See, there is something going on at this weird breakpoint. There is a function value, but you're never actually going to get the y value, I don't know, whatever this is, 2.5, because the break actually allows you to not actually need to cover everything from C to D. But if you're saying that the graph is continuous, if you're saying the graph never breaks, then somehow you're going to cross through every one of these y values in between on your way to get to D. Now, obviously C could actually be above D, or C could actually be equal to D. All you could really say, like let's do the crazy example, what if C and D were in the same place, then Actually, the only thing you're guaranteed is that somewhere else in the function, it's the same value. Imagine I drew this parallel. So sure, the function could do wacky things all up above and all up below, but all you're doing is you're saying there's some point in between where I'm going to touch the same value, or there's some point in between where I'll touch a y value in between. Okay, so with that being said, let's start doing some examples, and we'll see if we can get through this pretty quickly. So I'm going to draw up this scenario in a little bit of detail. Okay, so g of -1, that means that the x value -1, here the y value -2. Okay, so there's me graphing this out. And now let's see g of 3, so 1, 2, 3, is -5, -1, 2, 3, 4, 5. Okay, so you can see this is a case where it's like that number is bigger than the other number. Again, ignore my picture, but the idea is, again, if it's continuous, somehow I am going to go from -2 to -5, and I will touch every y value in between. So what that means is there is, let's see here, is 0, the y value 0, in between the y values -2 and -5. No, it's not. So that's not guaranteed. So A and D are out. -3 is in between -2 and 5. So if I'm moving between here to here, I'm moving between -2 to -5 because it's continuous somehow. So in other words, there will be some point where I am the y value -3 in between what? In between the x values of the function. It's a little bit wacky, but what you're saying is I will at some point be a y value in between the y values I was given for one x value c between the given x values. Okay, let's go through a few more examples a little more quickly. I'll still kind of draw up the scenarios here as we move along. Okay, so which interval must contain a solution where we could be -1? Okay, let's look at the y values here. If you look at the y values, now again, this is saying it's a continuous function, so just remember that you always need to read that. So if it's continuous, well, notice from -2 to 0, do your y values cross between -1? Yes, they do. On your journey on the number line to go from 1 to -2, you will cross -1 at some point, so that first interval is valid. Okay, what about on your journey from -2 to 3? Will you cross through -1 at some point? Yes, you will. So from x value 0 to x value 2, again, I'll just draw up that scenario. X value 0 to x value 2, just draw it like this, to x value 2. You're going to go from -2 to +3. So at some point, you're going to touch -1 in between. You have to. Now, it doesn't have to look like a straight line. I could do something wacky like this. Who knows? But because it's continuous, at some point, you're going to be the y value -1 somewhere. Okay, last but not least, what about from 2 to 4? Well, again, on your journey from 3 to -5, you will at some point pass through -1. So yes, actually, all intervals will work. Okay, moving right along. I'll just do 2 more examples so that you at least see 4 full examples, and I'll get away from pictures at this point. Okay, so I'm going from essentially 0 to 6 as I move from -3 to 3. So let's see here. What's in between 0 and 6? 5 is between 0 and 6, so this is what we can talk about. At some x value c will be 5, as long as we're in between the x values -3 and 3. So hopefully you start seeing that the solution looks very similar every single time. Oh, sorry, I'm going for the one with 5. The point is find the y value that's in between your endpoint y values, and then state that there's one x value, c, it isn't x value, you can see it's substituted where x is, in between those given x values, right? Again, hopefully you understand what I'm saying by all those pictures. Let's do this just a few more times. Okay, which interval must contain a solution where you're going to pass through 3? -1 to 2? Yeah, because 3 is in between 0 and 4, so that works. What about 2 to 4? 4 to 9? No, you're not guaranteed to get a value of 3 because 3 isn't between 4 and 9. What about from x values 4 to 5? Well, you'll encounter the y values 9 to 15 and anything in between guaranteed. Now again, here's what we're saying. Could could it dip down and touch 3 and then make its way back up to 15 somehow? Of course it could, but is that guaranteed? No. All we're guaranteed in this case is that it will cross in between 9 to 15, so not 3. So this time, the first choice is the only interval. One thing I also want to say real quick is what if they had said -1 to 4? Would -1 to 4 be a true interval? And the answer would be Yes, because from -1 to 4, you'd go from 0 to 9, which would include 3. Now, again, that wasn't an option, but I'm just trying to make the point. Can be a wacky concept, so we'll go through it again. Okay, so if we're going from the y value 2 to the y value -2, we'll encounter -1 along the way. We won't encounter 3, guaranteed. So we will get -1 somewhere from these x values. Oh, crap. I need to read more carefully. Oh, sorry, x values 0 to 4. See, that is a popular thing that you can do. Read very carefully, because notice I went with one x value between the y values. These are the y values, so make sure your c is between the given x values 0 and 4. That's the big mistake most people will make. Now let me redeem myself. Will I encounter -1? Yes, I will. Will I encounter -1? Is this the same example? It actually is. Cool. Okay, so there we go. Now let's move backwards and do, not backwards, but let's get our last assignment done. Okay, now this time we're arguing if someone else stated this correctly. So is the justification complete? Now, one thing you always need to read is, do they say, not does the problem say, okay? Because it even says the function g is continuous, but the person answering the question, Vera, has to say it's continuous. So they did say it's continuous, so that's good. Okay, now they're, essentially think about what we were looking at before. They're saying we go from -1 to 6, and 0 is between the y values. That's the same as saying, -1 and 6. That's true, so 0 is in between the n y values. So 0 must happen somewhere between the x values 15 and 20. Yeah, that's true. So we established that 0 is in between the given y values, -1 and 6. They're just calling them like this, but that's the same thing. And they said it's continuous, so that's complete justification. Let's go through a few more. Okay, a little bit of a different setup. Can we use the intermediate value theorem to say that you'll get 0.5 somewhere in between here? And this is a little bit more difficult, but you can't, because think about the x value 0. What is 1 divided by 0? That is undefined. In other words, it's not continuous. So the function isn't continuous on the interval, and that is the biggest reason why we can't move forward with this problem. 1 over 0, 0 is an x value in between this given interval, so it's not continuous. All right, we'll do a few more of these. Hopefully not speed this video up, I'll just talk fast. Okay, again, I'm just reading really quick here. Does Jasmine argue that the function is continuous? No. Well, we only have to choose one answer. You have to read the word continuous in the person's justification. All right, make sure you do that. Okay, up next, can I use the intermediate value theorem for this? Okay, again, this is definitely a more complex question. Is sine continuous? If you remember from our graphs, sine is a wave, it goes on forever, so yes, it's continuous. But is 0 in between these y values? It's actually not. Sine at pi over 6 is 1/2. Here it's root 3 over 2. It doesn't actually cross 0 in between these two. So we're going to go with no. Okay, up next, let me say this. They've told me the function's continuous. Okay, is 15 in between the y value 12 and the y value 23? Yes, it is, so both conditions have been met. Oh no, I have to speed up the video. All right, so, well, since I have to speed it up, I'll slow down a little bit and talk through this. Again, f of 4 means 12, and f of 11 means 23. So yes, 15 is in between 12 and 23. And yes, it's continuous, so at some point we'll encounter an x value in between here to get the y value 15 in between here. Okay, last example. They don't tell me the function's continuous. So done. So continuity is the most important part of this assignment. It will save you the most time. All right, hopefully these make sense, and hopefully the Khan Academy videos solidify that. Make sure you read through the worked examples if you ever get stuck as well. It's been a wonderful year. Keep on getting your assignments in, and